So if we want to talk about graphing tangent, I'm going to figure out my key points for this. And the way I'm going to do that is I'm going to use my unit circle. So remember how we talked yesterday that tangent has some values where it's undefined? Everybody remember that? So what I'm going to do is I'm going to have my set of key points, my reference points, start with something that's undefined and end with something that's undefined, and I'll have some points there in the middle. Okay? So for tangent is undefined when sine or cosine is equal to 0. You guys remember? Cosine is correct. Remember that tangent is sine over cosine. And we get something undefined whenever the denominator is 0. So let's find on the graph the places where cosine is equal to 0. So I notice it's here at pi over 2 and down here at 3 pi over 2. Everybody okay with that? All right. The little catch is that by convention, instead of using this value as 3 pi over 2, we use the angle that's coterminal to it of negative pi over 2. Remember, how do we find a negative angle? Which way do we go when we rotate? Clockwise. So if I go negative pi over 2, I'm going to this location, which is the same location as 3 pi over 2 when we go this way. Everybody's okay with that? All right. So our first key point is going to be negative pi over 2 and undefined. Our next key point is going to be here. But it's not 7 pi over 4, because really we're going in that clockwise direction. What angle measure is that actually? Negative pi over 4. And what would the tangent at negative pi over 4 be? Well, it would be the value for sine divided by the value for cosine. What do I get when I divide those two things? Negative 1. Everybody good with that? Okay. The next place I'm going to use is here at 0. What is the cosine here, or I'm sorry, what is the tangent here at 0? It's going to be 0 divided by 1, which is 0. Remember that tangent is sine over cosine, right? The next place I'm going to go to is here. So that's pi over 4. What is tangent going to be at pi over 4? 1. And then my last place I'm going to end at is here. And what did we say the tangent was going to be at this location? We already said this. Undefined is correct. So these are going to be our key points, or reference points, if you want to call them that. I think I use those two words interchangeably. They're meaning the same thing in this context. So we're going to use those to do our graphing, and we're going to graph just like we had for sine and cosines. Let's go and stick this back with our notes. Okay. Those are the key points for tangent. let's say we want to graph f of x equals -3 tangent of x over 2. So the first thing I'm going to do is identify my values for a, for c, for h, and for k. And I'm just going to look at the formula to determine those values. What's my value for a? -3. What's my value for c? 2. Everybody see why it's 2? I can think about this as tan of 1/2 times x. And my c is always the reciprocal of that coefficient, right? Good. What's my value for h? 0. And my value for k? Also 0. Everybody happy with that? So just like before, I'm going to write my transformation map. The way we do that is we write cx plus h, ay plus k. Should you have that memorized? Yes. And I'm not going to write the plus zeros. Is everybody okay with me not writing the plus zeros? I hope so. Now I'm just going to write down my 5 key points. Those I'm just copied down from the red box that we wrote above. Those were the key points. Every time I graph a tangent, these are the 5 points that I would use to transform. So if I transform my first point, what's my new x-coordinate going to be? Yeah, it's going to be negative pi over 2 times 2, which gives me negative pi. Okay? And what do I get if I take undefined and I multiply it by -3? So you get from my y coordinate. Still undefined, right? Whatever you have that's undefined, you can do whatever you want to it. It's still going to be undefined. Everybody's okay with that idea? What's the next point going to be then? So we'll do negative pi over 4 times 2. What do I get when I do that? Negative pi over 2, right? 2 times a quarter is a half. Everybody's okay with that idea? I just removed the pi's to make the multiplication or dealing with fractions a little bit easier. And then just put the pi back on at the end in my head. And I'm doing my mental math. Or on your calculator, you could do it that way as well. Just remember to put the pi's back. Okay. And then what will my y-coordinate be? Positive 3. Because negative 3 times negative 1 is positive 3. Okay. What's the next point going to be? Still 0, 0. Right? 2 times 0 is 0. Negative 3 times 0 is 0. Okay. My next point, what should that be? Positive pi over 2. Good. And then negative 3. So far, so good? And my last point should be pi and then undefined. So if we wanted to draw our graph, so let's see, let's do pi over 2, pi, 3 pi over 2, 2 pi, and then maybe we'll graph it in both directions. Okay. So the first thing I'm going to draw in are my two asymptotes. So negative pi, undefined, so vertical asymptote always. Positive pi, undefined. Everybody's okay there? Now I'm going to plot negative pi over 2 and then positive 3. So that's there. 0, 0. So that's there. And then pi over 2, negative 3. That's there. So to draw in my graph, should look like this. Try to draw it with a little bit of curve to it. It shouldn't be just like a dead set straight line. Anna? They're the places where the graph is undefined, right? Like these are the points I'm plotting over here. Okay, sure. All right, and now just like we did before, I'm going to fill the space, other space on my graph. So over here, I should have a point here and a point there. I could extend this like continue off the graph, but I don't need to. And then over here, I would have a point and then a point there. And again, I could keep going, but I don't. I filled up negative 2 pi to 2 pi, and that's really what I decided I was going to graph over. So this would be what my picture would be like. So this section in here, that's my one period, right? I'm just going to have those things over and over and over again to fill up any other space. What do you guys think? Just like graphing the other ones, right? Not a big deal. Different key points, and the graph looks a little different. It's not a sine wave, but like, no big deal. Do you want to do another one? If you're satisfied? Okie doke. What if we want to go from graph to equation? Let's grab the example from the text. That'll probably be best. Certainly be a little bit quicker than writing one on my own, off the cuff, so to speak. This is the book pages that I post to PowerSchool. You haven't looked at the book pages ever? Oh, okay. That's all that is. I was just pulling this specific example from the book because it's nice. Okay. So, same idea as if we were doing this for sine or cosine. There's two differences. One of them is, obviously this is a tangent function, right? How can you tell it's a tangent function? You just look at the picture. See the asymptotes on there? Like, tangent. Everybody's okay with that idea? Should be obvious that it's not sine or cosine, right? It looks nothing like a sine or cosine graph. Second thing is, the period. The fundamental period for tangent is pi as opposed to 2 pi for sine and cosine. Okay? Need to keep that in mind because that changes our formula for period for tangents. For tangents, period is pi times the absolute value of c, as opposed to 2 pi. Everybody's okay with that? We'll keep those two things in mind while we're doing this. All right, we'll start this the same way I would a sine or cosine one. I'm going to start by identifying the midline. If I look at this, where does it appear the midline is at? Y equals -1. I agree with that. Do you guys buy that? So right away I know that k is -1. Okay. How am I going to count for a period? What distance between what two things should I be counting? If you ask me, it's easiest to go from asymptote to asymptote. So this first asymptote is at -pi/4, and then it goes to +pi/4. How far is that? Half a pi. Everybody agree? If you go from -1/4 to +1/4, how far did you go? 1/2. Right? So I know that the period is equal to pi times c. Remember that was going to be important, we said. And then if I divide both sides by pi, or probably easier to think about this since the one side is a fraction, as multiplying by 1/pi, you get that c is 1/2. Or the absolute value of c is 1/2, I should say. We looked at the picture, and we just looked for the line that was going to divide it kind of in half. Is that okay, Matt? Okay. I don't want to make it more complicated than it needs to be. That's good enough, right? Okay. All right, to find the A, this is what I like to do. I like to locate this midline point, and I want to look at the distance from the midline point to the asymptote. I'm going to divide that distance in half, and then I'm going to track that up or down, whichever direction, to the graph. Everybody see that? This length, then, is my value for A. So going from -1 to 0, how many units did we move? 1 unit. So that tells me that my A is 1. Okay, so let's just state that one more time. So we have our midline point. That's here at 0, -1. It's a point on the graph that's on the midline. I'm going to look at the distance from that point directly across to the asymptote. I'm going to split that distance in half, and then I'm going to trace up or down to the graph. In the case, if I did it on the right-hand side of that midline point, we're tracing up. If I had done it on the left-hand side of that midline point, I'd be tracing down. Right? If I had done it over here, we'd be going down to the graph. Everybody okay with that idea? And I'm just going to count to see how long that little segment is. So again, I'm going to try to make this as easy as I can and just do some counting. Everybody's okay with that idea? Okay. So we found our value for K, we found our value for C, we found our value for the absolute value of A. We still need to determine the sign on A and the value for H. So to do that, we're going to use our parent function, which in this case is y equals tangent of x, that has a midline point at 0, 0. But just like sine, I need to also be concerned about what's going on surrounding that midline point. So let's go back and look at those key points that we just wrote down a minute ago. So here's my midline point. Immediately preceding the midline point is the graph above or below the midline? Below. How can you tell? Because this y-coordinate is less than the midline points. And then the point immediately following the midline point, is that above or below the midline? Above. Again, I can tell because the y-coordinate here is bigger than the y-coordinate at the midline. Everybody's okay with that? If you're a visual person, you could just plot those 3 points and look at the picture. That's certainly acceptable. So the way I'm going to denote this down here is I'm going to put a down arrow before midline point and an up arrow after midline point. In my transform function, the midline point that I'm going to use is going to be this one that's given to me. But realistically, you could have used any of these midline points. I don't know why you would pick one other than the one that's labeled, but you could. It wouldn't be wrong. But just like before, I need to be concerned about what's going on surrounding this midline point. So before we get to that midline point, our graph is below the midline. And then after that midline point, our graph is above the midline. If I compare those arrows, what do you notice? They match up, right? They're the same. So that tells me the A is positive. Everybody's okay with that? If the arrows were opposite, then the A would be negative. If one of the arrows matched and the other arrow doesn't, you made a mistake. They're either going to be exactly the same or exactly opposite. You can't have one that matches and one that's opposite. That's a mistake. Go back and look a little bit closer. And then just like before, the H is going to be the y-coordinate of our transform point. So putting this all back together again, I have y equals 1 is my A times tangent of 1 over c x minus h plus k. And since our k was negative 1, I'll just write minus instead of plus and negative. What do you think? Should we do another? Yeah, probably. This is probably the more difficult of the two skills. Graphing, usually not so bad. Okay. So, first thing we should find is midline. Take a look at the graph. Where is the midline at here? Y equals 2. Do you guys agree with that? So that means K is 2. Everybody's happy with that? Okay, next let's determine the period. Where do I look for the period between? Asymptote to asymptote, right? Okay. So this first asymptote is at negative pi. This second asymptote is at 0. So what is my period? Just pi. Right? Negative pi to 0 is pi units long. You guys agree with that? And since I know the period is equal to pi times the absolute value of c, what's the absolute value of c have to be? Just 1. We good with that? All right. Let's figure out what the a is next. So to do the a, I'm going to start at the midline point, and I'm going to go either left or right to the next asymptote. Doesn't matter which one you do. I'm going to find halfway on that segment, and then I'm going to trace up or down until I run into the graph. So I had to trace up on that side. So, how long is this segment that goes from 2 to 5? 3 units. Everybody happy with that? Okay. The last step now is to figure out my value for h. So on my parent function, we have y equals tangent. I'm always going to use a midline point from there. I remember for regular tangent, before the midline, the graph, or before the midline point, the graph is below the midline, and after it's above. So I'm going to denote it that way. In my transform function, I also need another midline point. What is the coordinate of the midline point for my function that I should use? I should use that is one of the midline points that I could use. I'm going to use that one because it's labeled for me. Could you use another one? Sure, but I don't want to go through the work of trying to figure out exactly what that point is. I know that one. It's given to me. One more thing I need to check, though, before I can determine my sign for A and my value for H. I need to see what's going on around this midline point. So, before the midline point, what direction should my arrow be pointing? Up. Because if I look at this part of the graph before the midline point, it's above the midline. And then after the midline point, obviously down, right? This part of the graph is below the midline. So, if I look at this, what can I tell? Notice the arrows are opposite, so it tells me the A is 0. And then the H is just going to be from the X coordinate of my transform point. And now I have everything I need. So negative 3 times tangent of 1 times X minus a negative pi over 2 plus 2. Or if I wanted to simplify that down a little bit, I could write tangent of x plus pi over 2 plus 2. What do you guys think? It's okay? Maybe? A little bit? Possibly? You gonna give it a shot? So from the homework, I guys want you to do 15 to 26. This is the last set of topics here for Chapter 3. Chapter 3? Chapter 3. So we have a test here coming relatively soon. We'll talk about this homework assignment next time, and then we'll get you guys post the reviews, talk about what the test is to expect, and then figure out where we're going to go from there, okay?